Ladies and gentlemen, good evening. Tonight we're going to look at Git. What is Git? A tutorial all the way from the bottom and up, so to say. So first of all, what is Git? Why do we use Git? How do we use Git? How do we get started with Git? Is there any easy way that we can actually know some tricks? If we already know a little bit about Git, how do we become masters afterwards? So this is what this video is about. First of all, what is Git? Why do we need Git? It is a source control management system. This means that it will actually keep audit with all the changes that is happening in the code base. It will notice which person does what. It will also notice the timestamp for when a change happened. It will also notice which branch this was done on, and it will also actually create an ID specific for the change that is actually created. So in the old days, before we got an SCM system, then we might have a myfile.txt, and then let us say that I wanted to make any change on this. Maybe this file was located on the corporate share on some drive that everybody could access, and then if I wanted to change this file, because this was a file that was used by many divisions maybe, then what I would do is I would actually take a copy, and then I would name this file underscore, and then maybe the day today, like this, 18 like this, so 18th of July, and then maybe _1, because this is the first change I want to do. And then it depends on what the agreement could be. Maybe I would actually do my change inside the myfile.txt file, and then every time I do a change, then I would actually create a backup that had a new name. So that means that the second change I would do to myfile.txt would then end up with another backup like this, 2022. And then 07, 18, maybe my name should also be in this file name right here, right? So I also add my name. And this is the second change I've done today, so I'll also add the number 2. So, and this was actually a way to handle, especially like spreadsheets and Word documents on a corporate share in the old days. But then we got this source control management system where we could actually get all of this handled in a more elegant way, and actually it could also empathize collaboration between people when they have a huge when they have a code base where we want to work together on, and that is named Git. So Git is actually a system where you have a repository locally. You have a repository remotely, and your colleagues also have that repository also. So that means that this repository, it is actually just an advanced history. So that means that if I create a change, maybe in the beginning I would create a file named myfile.txt, then I would get some kind of ID 1. This is a long Git hash that we get right here. Usually, I'll just write ID 1 just for simplicity's sake, and then I will have my name added right here also, and then we would have the timestamp would also be applied like this. And then it will say which file name it is, and it will also say which file, which change actually happened right here. Maybe it could be that the file has been created. And this is called the commit message. So there would actually be a message when we commit any changes right here. And that would also contain, if we are just changing some lines, it would actually also contain which lines has been edited. So this is the first change I do right here. Then after I've done that, then I would, the first thing I need to do with my file before I can commit anything is that I need to stage it. Stage means add it to the Git repository, added to the Git system, so it will actually be audited, and so changes will actually be noticed when I commit, when I do a whole commit. Because right now I only have one file, but I could have like maybe 10 or 20 files that all depend on each other, and that are actually kind of one commit, so to say. So I want to commit all of these files together, because these files are like a package that works together. So that is why it's called a commit, where we can have multiple files in it. So first I state the file or files. If I have multiple files, then I create a commit with a message, and then after doing that commit, then I can push my repository to the remote repository, and that means that if there are no conflicts, then then my remote repository will then have the same history as I had right here. So usually I would actually do a pull first to see if there was any changes from any of my colleagues, maybe. And then I would have to solve if there was any merge conflicts. If another colleague created a change in in one of the files that I also created a change in, then I had to solve these merge conflict. I have to manually look into what is the right solution. What is maybe I'll take 2 lines from my colleague, and maybe I'll take 8 lines from my code, and then I'll find out that this must be how what is actually intended with all of these changes. Usually, when there's a merge conflict, of course, you have to talk to your colleague and do the merge together a lot of times actually. So. But in 90% of the times, then there will be no merge conflicts, and you can just pull and push the codes, because usually then the changes that you make, especially if you're making incremental small changes during the day, and you commit and you pull and push very often during a normal day, then you would actually have no merge conflicts whatsoever in 90% of the cases. So then what happens right here, at some point, then my colleague right here, he will create a other file .txt, and the same thing happens. There will be an ID2 right here, and there will be a name, there will be a date as usual, etc., etc., etc. And then my colleague will then try to push this change. Of course, the file needs to be staged at first. You can see actually I prepared a readme.markdown file right here. So let us name this readme.markdown like this. So the file will be staged, and then it will be committed along with a message like this is the readme. This is a documentation for the project or something like that. Then after doing that, then my colleague, he tries to push the repository to the remote Git repository, but he will actually be denied and rejected because he forgot to, or she forgot to pull to do a pull first, and to get this ID1 incorporated into the history of the colleague's repository. So first, then we do a pull. And then when we do that pull, then we actually get this line right here, and there are no merge conflicts in this situation right here. I'll show you a merge conflict later on, don't worry. But let us keep it simple right here. So then after doing a pull, then I can see, okay, I got some new code. I'll just check what has actually happened right here. And I could also see that there were no merge conflicts. I'll run my unit test, of course, before continuing. And then I can see that, yes, of course, the person that actually created this code also ran the unit test before committing and pushing the code. And then I can see, okay, looks fine. And then the colleague then sees that everything looks fine. And then the colleague pushes this version right here to the remote repository. And now the remote repository is now a copy of this Git repository that we have down here. So all of this Git repository is actually a kind of a way to agree on which files, to agree on what is the real code world, so to say, which is a real truth, which files should be used when, and it is also a way to collaborate. In the old days, when Git just arrived, then one of the sales point was that Git is a distributed SCM system, source control management system. That means that if you're on a conference, then you don't need this remote repository right here. Then you can actually just pull and push to your colleague instead. If you don't have internet access to this remote repository, it was a nice story that was always told. And was one of the benefits that this was a distributed repository. This means that the repositories are distributed to other machines, to local machines. But it's just a situation that whenever happened, you would always have internet connection, and you will always actually use a remote Git repository. It was just something to make it easier to sell Git at that point, I guess. When I say sell, it is a free tool. So let us just go and see how we can get started with Git. So I'll just say Git SCM. Then I can go right here, and here we can see that it is. Here we also have to keep the buzzword Git distributed is actually right there. So that's small and fast. That's cool. Free and open source. Yes, that's a cool thing about it. It is free. And that is why it is so popular also. It is kind of the de facto standard. So if you want to be a professional developer, you need to know about Git. That's how it is. So here we have Git, and then we can download Git for our system. I'm using Windows right now, so I just downloaded with the Windows version. And if you want to install Git Bash, then definitely say yes if you're using Windows. If you're using something called WSL, Windows Subsystem for Linux, then you would install the Linux version instead on your WSL instance. If you use Mac, then of course you will click the Mac icon right here, and then you will install Git for Mac. And the current version right now is 2.37.1. And it is important that you and your colleagues actually have the same Git version, because they actually they behave differently depending on the version. And that means that if you help each other out with a certain situation and task, then Git will actually behave differently depending on which version it actually has. There are some the defaults has changed a lot during the years actually. So some behavior that was default some years ago, they are no longer the default. So that's how to get it. Just go to gitscm.com/downloads. Okay, so how do we get a remote repository? The easiest way, you can create a new repository two ways. You can actually go into a local folder, and then you can write git init, and then you will get a new repository initialized. But it's actually easier to create if you know that you're going to have a remote repository anyway. And of course you are, because one of the reasons why you want this Git is also you want it actually you also want it to be a backup of your code. So this means that if your local machines actually, so if you spill coffee in it, then you will still have your code located on a remote repository that you can use. So it also has this backup facility and purpose in it. So this means that we will actually always want a remote. We always want a remote repository, and this is where the money is made for a lot of these vendors. We have GitHub, we have GitLab, we have Bitbucket. We have a lot of these Git repository vendors, and actually most of them, they start out with a free plan, so it doesn't cost anything to get started. Then at some point, if you want to collaborate or have a large number of private repositories, a public repository is a repository that everybody can see, and that is what I'm going to create here in just a couple of minutes, so we can see how to create a new repository. A private repository is one where you can delegate, you can give access to people you trust and people you want to participate in your project too. So that then we have all of the security part also included. And I'll talk a bit more about security in just a couple of minutes right here. So let me just see right here. So I'll already create this Git demo 2. I've already created one demo, so I'll create another demo right here. Then I will give it some description. Tutorial of Git, something like that. I will not mention all of the commands, but we will go into something called cheat sheets. So the cheat sheets commands, and then we will see what we can actually do. Add a readme.markdown file, yes, why not? Add a Git Ignore file, yes, why not? And I'll just choose the Java one right here. So these are all features, and this UI right here will actually be the thing that is different regarding whether you're using GitLab, Bitbucket, etc. Now I've actually created my Git repository. I can then clone the Git repository by going to code, and then I can say I want to use SSH. You always want to use SSH, because then you can use something called a key. You will create an SSH key pair. You will have a private key and you will have a public key. The public key you can add to GitHub. Then they will actually know that this is you actually cloning this project now. The private key can never be given to anyone, because that is actually the key that can decrypt data between you and any server actually. So it means that if someone gets your private key, then it can actually pretend that they're you, and then they can go and steal all of your code. So of course the private key, never give that away. The public key, you can give it to anyone, because the purpose of the public key is to encrypt data. So it is okay that someone encrypts data for you, but as long as it's only you that can decrypt that data, right? That's why the private key is so important. Private key decrypts, public key encrypts, and that's why private key is so important. Never give it to anyone. Yes, okay, so now we have this line right here. I'll go and then I'll open Git Bash right here. I will go to projects, or actually I'll just say demo. Don't have a demo folder. Yes, I have a demo folder right here. Then I'll write git clone, and then I'll clone the code by pasting that line that I just got right there. Okay, so first of all, I already have a SSH key pair, but if you don't have that to begin with, you won't have one. So that the way to handle that is you will go write SSH keygen like this, SSH keygen like this, enter, and then it will ask where should it place this file. Then you would say that you should place it in this folder right there, and then name it something else like demo2 like this. Enter. And then ask for a passphrase. So this is if you want access to your keys, to your private keys. Should there be used a password on top? I'll just press enter. I don't want any password. The default encryption for these keys are RSA3072. So that means that if I list what is in my SSH folder right now, then I can see I have a demo. And I have a demo2.pub. The demo2.pub, that is the one that I can show to other people, and that is the one that I can add to GitHub. So I'll just like write cat, and that would actually give me the content of that file right here. So here I have the file, and then I will copy this, right-click copy. Then I'll go to GitHub to my account. I'll just show where it is. I've already done it, but of course I'll just show where to do it. And then we say settings right there. And here we'll see something called SSH and GPG keys. And here we can then say new SSH key, and then I can then paste in my key, and then I can give it some kind of title, so I know that this is actually this key that I created on this machine right here. And that's actually then you will be validated okay when you try to clone your private repositories. This is a public repository that I just created now. And this is because there's a limit on how many private repositories that I can have before the price plan change. That's why I chose a public plan right now. So, but I have this repository right now. I have a Git Ignore file. I have a readme.markdown file, and let us go and see. Let's go and see if we also have that in our Git demo2 folder. We got this folder right now when we cloned the project. And I have a readme. And I also have my Git Ignore file, and then I have the .git folder right there. The .git folder, that is actually the repository, and it will be placed in the root of your folder, in the root of your Git project. So that's actually a quite good start that we're already in now. But how do we know which commands to write, and how do we know how to use Git? And that is a very good question. We will just write Git cheat sheet like this, and then you will actually get a cheat sheet from each of these repository vendors. There's one from Atlassian, that's actually the first one, and there's one from GitHub. I'll take the one from GitHub because I'm using GitHub right now, but they are almost the same. So if you open one of the other ones, you will actually see the same commands. So Git Status is something that is important, and we can get a status for which files are actually stage, and which files should be in the next commit, etc. We can also add a file. This will add this will state the file. Add equals stage. Reset is if we regret that if we have a file that we don't want to stage, then we can write reset. Then it will still be on your local machine. It will just not be a part of the Git stage. It will not be staging Git. Before we continue, actually, then there's something that we need to run. We need to configure Git, and we do that by giving a name. So it needs to know that my name is Mike, and that means that then it will actually stamp all of these changes with my name. Whenever I commit some code, then it will create a new Git hash ID, and then it will also stamp it with my name. So that's why it needs my username right here. I also need to give Git my email. This is especially a good idea if you are running some kind of CI tool, a continuous integration tool, which will actually test the code. Every time you push some code, then it will test it. And then if there's an error, something that breaks the CI pipeline, then you will actually get an email that says, you broke the pipeline, there's something wrong, please go and fix it, your code is flawed. Then we have git config right here. That is the color. That does matter. Let us not talk about that. Git diff. This will show the differences of what is changed but not staged. There are some of these that are not that important. This is very important. You'll use this all the time. So we have git commit -m for message and then some kind of message. This will commit all of the changes that we made, and then we can after that then we can actually push the changes to the repository. And let us try to do this right now. First of all, I want to use VS Code, especially in the beginning. It's a good idea to use an IDE, integrated development environment, where you can actually have many of these. That will actually help you with all of these Git commands right here. So this is my Git demo 2 right here, and I will update it later. Yes. And here we have my project. This is my project right here. I will now create a new file. This could be a pie recipe.txt like this. So this is my recipe, and what do we need? If it's an apple pie, of course we need some apples. We probably need sugar. We probably need some flour. Maybe we need some other things like nuts, like raisins. I'm not that good at baking apple pies, as you probably can see there. So let us stop there. This is our recipe, right? This is fine for now. So let us just see what actually we can see with the git status command. So we can click here in VS Code. This is VS Code. It's free to use, the open source version right here. If I click right here, then I can actually see there's a file that is in the changes section right here, and I can click the plus if I want to stage the changes. I don't want to do that right now. I want to use the command line to get a hang of Git. So first I'll write Git status. And then I can see right here, there's an untracked file, pie recipe.txt. Yeah, okay, let us add that. So I'll write git add pie recipe like this. Then I can write git status again. And now we can see, okay, now there are some changes that just need to be committed. So this means that now pie recipe is under Git's control. The changes will then be monitored. And whenever I do any change right here, then Git will actually recommend that I commit I committed the change. So let us do that. So I'll write git commit -m for message, and then I'll say pie recipe, and then enter, and then we'll say, then write git status again. And here we can see that now my branch is ahead of origin main. Main is the name of the branch. We have not talked about branches, and we will not go into details about branching in this video right here. I'll just mention to you that there are different branches that can be used. For this demonstration, I will only use the main branch. If you use Git Flow, then you will probably have many branches, like a test branch, and you will also have a development branch, and you will probably also create a new feature branch for each feature that you work with. This is not a very efficient way to work. It's actually quite inefficient, but it can give some kind of security. If you have a rigid process, then you can use the Git Flow. I would not recommend it. I would definitely recommend trunk-based development instead. Trunk-based development is much faster, much more efficient. You work together with your colleagues. You just have one branch, maybe named development, that you code on. And then at some point, then you can make a new release branch from your development branch. And then you can, the code from the release branch can then go through the pipeline and then go into production at some point. So trunk-based development, just search for that with Google, and you will get a lot of descriptions on how to code that. But that is something that you have to agree on in the team, on how to use the branches. Right now we don't use branches, so this will actually be kind of like the trunk-based development strategy that we use. We only have the main branch in this situation right here. If it is if it's your own project, or maybe just with a friend, then just keep it simple. Just keep it with one branch. The thing is with branches is that you cannot see the other people's code. So if I have one branch that I name Mike and you have one branch that you will name Jane, then your branch will not be seen by me. So every time you make some code changes, then I cannot see your code changes before we actually merge or rebase the code between these branches. So yeah, keep it simple, especially to begin with. So now we have committed this code, but I am right now my local repository. My local repository right here, it is actually ahead of the remote repository with one commit. So I will go and I will push my code. So I'll write git. Before I push my code, I will always run git pull. So that is a good thing to do by git pull, because someone else could have made some changes. Push like this, git push, enter, and let's see what happens. So now it actually copied the code up to the repository, and we can go look at the console right here. I'll press refresh. This is GitHub. Now I can see I have my pie recipe right here. And now on purpose, I will actually make a conflict so you can see how a conflict looks like and how to solve the conflict. So I'll edit my recipe right here. I will remove the nuts because I don't like nuts in this, and maybe I'll add some. Maybe I'll add coconut instead, and I'll add it up here. Maybe I will say there should also be some oranges. And I don't like raisins. We need to remove that, right? And then we need to add some milk instead. So I've made a lot of changes right now. I can commit those actually by using the web console on GitHub, and then I can just write something like yikes, no raisins, or something like that. And then I'll say commit it directly to the main branch. Yes, do that, and then commit it. So now I've actually committed some code, and I'm not aware of that on my local repository when I sit here and code, and when I sit here and write my recipe. I have no idea that this change has been made. So I will actually continue with my recipe. Apples, maybe I'll put this should be 5 apples, and maybe it should be like 1 kilogram of raisins, and it could be like 10 kilograms of nuts, and it could be 1 kilo. This is a huge batch right here, maybe, but it does not matter. So maybe I've changed and added some stuff right here, and I wanted maybe to add 1 liter of water. 1 liter of water right here. So now I've made a lot of changes, that's fine, and I will, this time I'll use VS Code just to show how to use VS Code. So first we will state the change by pressing plus right here. The good thing about using VS Code is that you can kind of cherry pick what you want to stage and what you want to commit. I would recommend that you actually always pick that you stage all of your changes and that you commit all of your changes, because usually your code is entangled, and suddenly then you would actually have committed and pushed some code where there was one file that you forgot to stage and commit, and then your colleagues will then be stuck with some code that doesn't run. And that is also why it's important to have a continuous integration pipeline that tests the code and runs all of the tests on the server. On some server, and that's a good choice. A good choice is actually GitHub Actions, Git Actions up there. I will make another video where I will show you how to use that. And there's also something called Circle CI is also excellent. Jenkins is also excellent. I have made other videos about Jenkins. Look at those if you haven't done that already. Okay, let us now we'll make some a new Git commits message right here. I'll say add water. So I've added some water right here. I'll press Control Enter to commit this change, and then I'll press Sync Changes. This will then pull and push the code. And what do we get right here? We actually got a conflict. We actually saw here right now, we have 2 developers that changed the same file at the same time. Not at the same time, but they changed the same file, and now we have a conflict. The head that we see right here, the head, that is your version. So the head is your version. And the other version that comes down here, this is the version that comes from the server, and it also has this is the Git Commit Id, and this is the ID. If I go to and look in history, then I can find this ID if I want to see who actually made this change. Actually, let's do that. Actually, that was actually an excellent idea. I just got that. So I'll write git log, and then I can see right here that this ID that I write there, and let me just check, was it that ID right here? We have something. FEC 581, let us just check right here. I can actually not check it yet, and that's because we're still merging. So if I want to see that ID, then I have to go to Git to the GitHub right here. Here I can see my. Let me go and see my. I want to see my commits. So we have one branch right there, and that is main. And here I can see my commit somewhere. Here there are 3 commits. And there I can see that this is my update for my pie recipe, which is right here, and I can see that this is the ID for that. So now I need to merge the files. There are tools where you can actually write Git Merge, and then you will actually get an editor. So you can actually merge you can actually use an editor to solve the merge conflicts. To begin with, and to know what's actually going on, then in the beginning I would actually say just do it manually. That means you will change these things that will actually help us right here, so that I now know that this is actually the bottom one is for from the server, and the top one is for this is for me. And I definitely want to add the oranges, so I'll just move the oranges up right here. And what about the apples? I'll just delete that line. I already have the apples right there. The coconut, okay, that is also something that could be nice to have in my recipe actually. So I'll add that also. The sugar, I already have that. The flour, I already have that. I'm more specific with the amounts. And the milk, oh yeah, milk is actually a good idea instead of water. So I'll delete the water and I'll save 1 liter of milk. So now I've merged this recipe. And then now I can actually say that it has been merged. And the way that I say this file is fine is actually by writing git add and then the name of the file, or I can just press plus right here inside this UI right here. So in the beginning, then definitely, and then it actually says, the UI actually says you can commit this with this comment right here where it says merge branch main with with whatever you got from the server. Then I just press Control Enter, and now my merge has now been committed, so then I can synchronize again. Because now I have 2 changes. I have the change that I made, and then I also have the merge. And if I go and look on my server now, on GitHub, then I should see that the recipe has been updated with the merged version. And yes, it has. I have my milk now instead of water. I have my milk now instead of water right there. I have my oranges, and I also have my coconuts. So that is how to solve merge conflicts. That's the git log. You actually just saw that. Let us write that again now. Now there's a bit more in the git log. We can actually see that someone actually removed the raisins right here, and we can also see that I merged something right here. There's an author of all of these changes, so that means that if I am not, if there is some commit that I'm not satisfied with, then I can go talk to that person, and then we can agree on whether to remove his code, or maybe my opinion was actually wrong. That could also be. Always talk about your code as whenever there's something you don't agree on. Talk about it. Go to the coffee machine, talk about it, and then you will actually figure out a solution that is actually best for the project. There's always, even though there's several ways to do and to solve problems with a program, then there's always one that actually has more pros than cons, and that is what you can try to discover by the coffee machine and by discussing code and commits and how to do stuff in general. Okay, so let us go back to the cheat sheet just to see if there was anything that we want to. I don't want to show the branching, git branch. Look into that if you want to continue with some stuff. Then you can create a new branch. Git checkout, then you can actually go to another branch. So all of this is actually branching right here. And you could also have merged with the branch if you want to. When you're reading up on merging and when you're trying to merge, then also try to check out the rebase, because rebase is just a more advanced merge where you actually change the history a little bit, but it looks you get a nicer history afterwards. But in the beginning, just do git merges, and then when you feel comfortable with that, then try to read up on git rebase also. This is how to create a repository. We can write git init, and then we can get a new repository from the repository server by using git clone. This is what we did. We did the git clone way. If you want to, you can try to create a folder and then write git init inside that, and then try to get that to the server afterwards. It is not as difficult as it sounds, because GitHub will actually tell you how to do it. I will not tell you how to do it. It needs to be a challenge. It's not okay. I will tell you how to do it. It's not that difficult. You will just go and create a new project. Of course, they have made it easy also. So I'll go and then I'll say, then I will say new project. If I could find that button, it's right there. New button, new project, and then I have this one right here. And then I would not initialize it with any files in the beginning, because I already have those. And then I have to set my remote, and then I also have to let's call this Git demo 3 description. I'll just leave it out. I don't want any files in it. So now I have in this situation right here. I already have an existing repository, and then it actually gives you all of the commands right here. So it says do change in your own local repository. Actually says do a change in some folder, initialize your local repository with this, state your readme.markdown file, make a first commit, create a branch named main, and then set the remote. This is the most complex one right here, because we have to say to Git that the remote server is the server right here. It could also have been Bitbucket. It could also have been GitLab instead of GitHub. So this is the most complex one right here, Git remote add. And then after that, then push to the origin like this, -u, because so you get so you can push to the remote host named origin. You want to push the main branch right here. So this is a recipe if you want to go for the git init way instead of. But the easiest way when you start a new project is to create it right here and then just clone it locally, and then you're good to go. Then you will get. Then you don't have to write this long command right here. Of course, you will not write any of this. So you just press the copy button right there. Maybe sometimes I create a shell script .sh file, and then I can just run that with all of that stuff inside it. Git log. This is very important. At some point, you will actually you have to look into the history and find out. You'll find some mess. You'll find out that there are some folders have been refactored, and you want to find out who did that, and that you want to run the blame game at some point, right? And when I say that, of course, I don't mean it. You should never blame anyone. You should, of course, talk about the things, and that's the reason why the other person did like he or she did. So you need the git log. The git log will show the history, and you can also show. You can also show cool stuff like commits that are on branch A but not on branch B. You can also try to follow one file if you want to, in the different commit IDs. And but that's actually one thing I would actually recommend you to do instead of using all of these commands in the terminal, and that is actually to use the built-in features for Git for your IDE. And it doesn't matter whether you're using IntelliJ, WebStorm, Eclipse, maybe you use Sublime, or maybe you use VS Code. It does not matter. The IDE that you're using, they usually have if they have a good Git integration, then use the UI to begin with there, so then you can actually filter. Then you can filter out the stuff that you don't need, and you can then see which files has been changed when. Yeah. So, and here we have some more commands. What is this? This is here we can add a remote. That was the difficult line that I showed you just before. This was how to add a remote repository. I think this is actually, rewrite history. This is the advanced part. When you think you know everything and you think you are a world champion with Git, go try to rewrite the history with rebase. And don't use hard unless you really know what you're doing. So, yeah. Then there's another thing. There's a Git Ignore file that can be created, and then inside that file we can actually have a pattern where we can remove all of these. Then we can actually state which files do we not want to put under Git. You don't want to put binary files in Git. You don't want to put YAR files, tar files, tarballs, and you don't want to put compile code. You don't want to put that in Git either. You want the source code so you can compile the code. You don't want to place all binary files, or all zip files, files that can generate files. You don't want to replace those in Git either. All files that are being generated, those can always be generated again, of course. So don't stage those files, and you can filter out all of these files by creating a Git Ignore file. It's actually, we already have one Git Ignore file right here, and there's a good beginning right here. It says that all of the class files, keep that out. We don't want log files, of course, either. Log files is usually just so we can see some debugging situation, and we don't want that either. I hope you learned how to get started with Git. Definitely use the cheat sheet, and also use the ID, the integrated development environments. Thank you very much for watching. Have a great evening, and I hope to see you again soon. Bye bye.